it is a reflection of exponential curve in a mirror which is at 45 degrees to this coordinate system, which is giving you the log function. So let's take another example. These are mirror images of each other. Now you can imagine there is nothing special about these two functions. Take any function, when you are talking about inverse, the entire thing will go through, but you'll have to take care of the fact that your function, when you invert, should not be multivalued, okay? So we'll come to those things later when we look at inverse trigonometric functions. Okay, so these are some facts about functions and their inverse functions, relation between them. Now, I made one important observation. I mean, these are all important observations, but one observation which I will again carry forward in that direction is that log of x grows as x increases. That we have seen, right? Log x is growing function, it grows, but log of x is always less than x, right? Where x is positive. Remember, log at your age is not defined for values, for negative values of x, right? You remember this? Log function was always below this y equal to x line. It was going like that, okay? Now we will compare few more functions and how they grow. What's the relative growth? Not quantifying it, but knowing the behavior. So I want to take some exponential functions and compare how they grow as x becomes large. So I want to know, for example, how 2 power x grows, how 3 power x grows, how e power x grows, how log x grows, how x grows. Okay, how all this compare with each other. So let's start first with the exponential function. These are all exponential functions, right? So they will all behave similarly. I will tell you later why, but they will all behave similarly. I mean, not later, you know, right? It's 2 power x or 2.1 power x or 3 power x, they will all behave similar way. And I will take this and compare, more importantly, forget this one, compare how exponential functions grow compared to polynomial functions. X square, x cube, x4, etc. Okay, or you can make any polynomial x power 4 plus 3x square plus 1, okay, like that. So I want to compare growth of polynomial functions with exponential function, okay? And I, instead of looking at these two, I will just look at e power x, because that captures how exponential functions grow. Is the goal clear? Yes. So let's do that. Let's put a line y equal to x. Okay. That's y equal to x, okay? It's okay. Fixing will require 2 hours. So that is y equal to x. Now, let's plot x square, x cube, x to the 4. X square x cube and x to the 4. Okay, at x equal to 0, these are all at 0. So when x is equal to 0, all of these are equal to 0. When x is equal to 1, all of these are again equal and equal to 1. Correct? So all these curves meet at this point and again meet here. Yeah, this graph is, it's not good. So this point you remember, okay? They all meet at the origin and they will all meet here. So I will just remove it. otherwise I will have trouble. Let's see. Is this okay now? This is okay. That is y equal to x. Now, x square, let's draw x square. Okay, something of this sort. Then I draw x cube. X cube will grow faster than x square for x values larger than 1. Is this point clear? Right? But it will have lower values compared to x square when x is below 1. So it will have this shape. Something of that sort. Let's draw x power 4. It will be further smaller for small values of x, but it will grow faster. Okay? So this is x square, x cube, x to the 4. Okay, I am not drawing for negative values. How about e to the x? E to the x, this is 1, so e to the 0 is 1, so it grows very slowly, very, very slowly, then it starts picking up. That's exponential function. Which one is growing faster, e to the x or x square? E to the x. Which one is going faster, e to the x or x cube or x4? It's faster than all of them, right? Because if you look at any value of x, they are here. This guy is already there. If you look at this value, they are here. That guy is somewhere there on the top of the roof. Okay? If instead of x cube, you had x cube plus x square, even then e to the x wins. Right? Because x cube plus a little bit of this one will take you here, but that guy is there. Okay? So e to the x grows faster actually than any other polynomial, not just these three. So I'm not giving you proof, I'm just telling you a statement that e to the x grows faster than any polynomial function. Okay, where n is some integer. Okay, so take any n, let's say 2, x square, 3, x cube, x4, x5, x10, whatever. Exponential function will always win. After some values of after some value of x, exponential function will always start winning. It will always be larger than x to the n. Okay, that's something important to remember. Now, here that y equal to x, and you remember log function is the mirror image of that. So this is 1, right? So it should have passed through this, and as I said earlier, it always grows slower than that. Any questions? Make sure you remember these points. So I'll give you some simple results. So I have been saying that log function is defined to some base. Right now when I was talking about e to the x and the corresponding log function, where it was implied that the base is e. Okay. Now suppose I give you a log function in some base, log of x to the base b, and I want to write the same expression, same thing, but now to the log to the base a. How are they related? How log of x to the base b is related to the log of x to the base a. Okay? So change of base of log functions. Okay? So what I want to do is take log x to the base a and find a relation of it with log of x to the base b. Okay, where both a and b have to be greater than 0, right? Because base has to be a positive number. Now that's easy. I think it will be easier if I don't look at it. Always confusing to look at note. So y is equal to, I want to start with, does not matter, let's say b power x. Okay, let's say y is equal to b to the x. Now suppose, now b is some number, but b can be written as b as a power some alpha, right? So let's say b is 25, a is 5. So 5 power something would be 25. That in this case is 2. But even if b was 2.7, 2.7 raised to the some number, some rational number would give you that one, right? So you can always find this, such a relation. So with this I can write y is equal to a power alpha power x is equal to a to the alpha x. Correct? Are you already getting an idea what needs to be done next? I'm getting. Okay. From here, if y is b to the x, then x is
log of base b.
agreed? If b is equal to a to the alpha, then alpha is correct. Then alpha is log of b to the base a. Very good. If y is equal to a to the alpha x, then alpha x is, so alpha x is log of y to the base a. Correct? This is fine. Now let's substitute what is x, what is alpha in terms of logs. So alpha is log b to the base a times x is log y to the base b, and the right hand side is log y to the base a. Correct? So log y to the base a is log y to the base b times log b to the base a. Okay, it's easier to remember it this way. If you take log, so you take this, keep it this here and take that one on the other side. Log y to the base b is equal to log y to the base a divided by log of b to the base a. So in this case, the right hand side, both the logs are to the base a. Okay? But in that expression here, the left hand side, pay attention here. On the left hand side, this was to the base b, this was to the base a. That's why it's not looking so nice. But here, What we have done is, if I am given a log of y to the base b and I want to know it in terms of base a, you find out what is y to the base a, but divided by what is b to the base a, where b is this. Is this fine? So that's another very useful relation to know. And of course, if I choose, oh my goodness. If I choose a equal to e, where e is that number 1 plus 1 plus 1 over 2 factorial, 1 plus over 3 factorial and so forth, then it becomes log of y to the base b is simply log of y over log of b. Nothing, there is no simplification, it's just you don't write e.
ln.
Yeah, you can also write ln, very good. Or this. Correct. Natural log. So if I don't write the base, usually it means natural log, or it is understood what base is being talked about. Okay.